Hello everybody. Today's shout out we're going to have to wait a second for because if we start right away he would miss it because he's always a good couple of minutes late for class because he's walking someone else to class. Our first shout out today goes to Donnie. What I miss most about Donnie is what a good sport he was. He let us always pick on him, but he was always a good sport about it. And Gotham has started a rumor saying that you're going to Keith Tech. Is that true or is that just a rumor? Today's goal is that you're able to factor the GCF from a polynomial. So let's get started. In factoring GCF, you actually did before. You factored GCFs before in 6th grade. So we're going to build off of that and just include more pieces to it. So to factor a GCF from a polynomial basically means to unfoil or undistribute a polynomial. So if this was our polynomial, we would be looking for what is the largest number that would go evenly into every single term, and what is the most amount of each variables that they have in common. So if we look at our numbers, our numerical coefficients, we have a 4, -16, an 8, and a 12. The largest number that goes into all of those terms would be a 4. And then if we have 4 x's, 3 x's, 2 x's, and 1 x, the most amount of x's that they have in common is 1x. This is the GCF of that polynomial. But when we factor, we don't only take out the GCF, we tell someone what you need to do to get back to the original polynomial. So we're going to set up an actual multiplication problem with some parentheses. The GCF will go on the outside, and we want to list for every single term what you would have to multiply the GCF by to get back to the original term. So to get from 4x to 4x to the 4th, we would have to multiply by x cubed, because that's how much it's missing. To get from 4x to -16x cubed, we'd have to multiply by -4x squared. To get to 8x squared, we'd have to multiply by 2x, and then to get to 12x, we'd have to multiply by 3. So this is factored form for that polynomial. Here's our GCF, and in the parentheses is what you would multiply the GCF by to get to the original. And you could check to see if you did it right by doing the rainbow to see if you get your original. So for the first example, it's just a binomial. We're going to see what we can take out for numbers. So if we look at 12 and -9, the largest number that goes into both evenly is 3. If you have an a squared and an a, the most a's they have in common is 1. So that's our GCF. So if you're asked for the GCF is 3a. If you're asked to factor, you also need to give the parentheses. So 3a times 4a would give us 12a squared. 3a times -3 would give us -9a. So this is complete factored form. If you're asked for the GCF, it's just the 3a. For the next example, 18 and 12 are my two coefficients. The largest number that goes into both of those evenly is 6. If we have an x squared and an x, the most x's they have in common is 1x. And then my parentheses, 6x times 3x would give us 18x squared. 6x times 2 would give us 12x. So this is complete factored form. This is the GCF. And for the last example over here, 96x cubed and 48 minus 48x squared plus 60x, the largest number that goes into all three of those evenly is 12. The most x's they share in common is 1x. And so in parentheses, to get back to this, I would have to multiply by 8x squared minus 4x plus 5. So your GCF is 12x. The complete factored form is this. Now before we go on to the very bottom, I'm just going to do one other example. I'm just going to switch this middle one. If this had said negative 18x squared plus 12x, In math, we don't like to have the leading coefficient be negative. So if the leading coefficient is negative, you're going to factor out the negative as part of your GCF. So if you were asked for the GCF here, it would now be negative 6x. And so in parentheses, you would have 3x minus 2. So we don't like the first thing in the parentheses to end up being negative. So if your leading coefficient is negative, factor it out with your GCF. Now, one reason why we do factor is so that we can solve a polynomial. So solving a polynomial involves finding all the places that this polynomial would cross the x-axis, which we'll talk about more in the next chapter. But the reason why we can use factored form to help us solve this is called the zero product property, which just says if you have two things being multiplied and the answer is 0, one of the two things had to be 0, or both of them have to be 0. So 4 times 0 is 0. 0 times 4 is 0. 0 times 0 equals 0. So if a times b equals 0, either a is 0, b is 0, or they're both 0. So in math we call that the zero product property. And we use this to help us solve equations, to solve polynomials when they're in factored form. Solutions to these equations are called solutions, roots, or zeros. So you will see all three of these words associated with solving equations. They all mean the same thing. So for our first example, we're going to first bring everything over to the left side. So 9y squared, I'm going to bring the 21y over as negative 21y equals 0. Now on this side I'm going to factor out my GCF, so my GCF would be 3y, and then in parentheses I would have 3y minus 7. So I know that if you take this and multiply it by this, you get 0. So that means either 3y has to equal 0, or 3y minus 7 has to equal 0. I'm going to solve both of these equations to get the two possible solutions for this equation. 3 times 0 would be 0, so one solution, or root, or 0, is 0. My other one, if I solve this equation, I would have y equals 7/3 as my other solution. So these are the two solutions, roots or zeros, for this equation. For my second equation, I'm going to first bring everything over to the left. So I'm going to bring the 8k over. So I'd have 4k squared minus 8k equals 0. Now I'm going to pull out my GCF, which would be 4k. And then in my parentheses, I'm going to have k minus 2. So now because of the zero product property, I know that either 4k has to equal 0, or k minus 2 has to equal 0, in order for this times this to give me 0 for an answer. So now I'm going to solve these two equations, and k is either 0 or k equals 2. Are my two roots, solutions, and zeros. For my next example, I'm going to bring over the 16q to the left side. I'm just going to bring this up. I'm going to bring over the negative 16q, so I'll have q squared plus 16q equals 0. Now I'm going to look for a GCF. My GCF is just going to be q because I have a 1 in 16. And then in parentheses I would have q plus 16. And if I solve these two equations by making them both equal to 0, I will have q equals 0, or if I solve my other equation, 2 plus 16 equals 0, I get q equals negative 16. So my two solutions roots or zeros are 0 and negative 16. For our final example, I'm going to bring over the 36h, so I'm going to have 12h squared minus 36h equals 0. I'm now going to take out my GCF, which would be 12h, and then set up my parentheses. I would have h minus 3. So now I know that either this equals 0 or this equals 0. So I'm going to write my two equations, 12h equals 0 and h minus 3 equals 0. So if I solve both of these equations, I would get h either equals 0 or h equals 3. And those are my two solutions, roots or zeros for that polynomial. Have a good day.